Okay, so I'm just going to provide a quick overview and some use cases, more of scenarios really of when unknown unicast can occur and then you want to protect. There's some details about the feature. I'm going to provide some basic configuration around that and really some not troubleshooting, well, sort of troubleshooting, you see what's applied on the interfaces. There's some good resources around that as well that I've linked in. And then I'm going to go to a live demonstration about the behavior of unknown unicast rate limiting. Okay, so let's go into a quick overview. So I guess unknown unicast rate limiter is there to curtail unknown unicast traffic, because it's pretty much a bad thing to happen on your network if it gets too much. Okay, so unknown unicasts are effectively an unintentional behavior that happens in a network when, say for instance, as shown in the graphic here, a host is trying to communicate to another host, but actually that host is no longer there or disappeared. And it turns out that the switches will then take that unknown unicast, i.e. I don't know where B is, I'm trying to transmit to B, and it will turn that unknown unicast effectively into a broadcast into the whole network in a layer 2 domain. So if you've got some stacked switches and you're in a large layer 2 domain, if this can sort of cause an avalanche, which is not great for the network. It's going to cause performance issues on your network. It's going to stop applications behaving properly. And effectively, it's like a type of denial of service, if you think about it. Okay, so that's what unknown unicast is, and this is why we have a rate limiter for it, to protect ourselves and control and have some predictability in the network so we can stop the bad things happening effectively. So as of prior to 10.6, we used to support, we do support it on the 8400, 8325 and the 8320. Now, as of 10.6, when it's released, it will be on the 8360 and all the 6000 platforms, and I'd expect it to come on to other platforms as they are released to give this consistency across the platforms. Okay, let's look at some use cases, more of when this can happen. So for instance, if you've got a large MAC address table and you've got a large number of hosts on a device, and these could be disappearing or even flapping because the switch can't cope with it, you're going to potentially get unknown unicasts here. And I've got an example here of on our switches, you can run a layer 2 MAC diagnostic and you can see how many MACs. So if you look into detail there, you might even be able to see some sort of errors or hosts recycling a lot. This could give you a clue. Actually, this is the problem that I'm experiencing, and it could be causing unknown unicasts, and therefore this maybe I need to apply that somewhere on my port. So that's just a useful snapshot. We can do that on our CX devices, and you can see it says cache. There's always a reference to cache all the time. So you can get host uptimer differences and caches, so that could cause a problem. You get spanning tree topology changes that can cause flooding as well. So again, that's another scenario where you can get unknown unicasts. Obviously, some of it is required, okay, but some of it, if you get too many changes, obviously you've got other issues with your network, but you're also going to get unknown unicasts occurring. And also you can get faulty NICs, a flapping host, flapping links. This can cause unknown unicast flooding behavior effectively. And I've got a demo towards the end that shows that and tries to simulate that. Okay, so let's go into some details. So The rate limiter is only ingress, so it is only applied ingress to the port, so traffic coming into your switch, that's where you will curtail that traffic. It's only applicable to a layer 2 domain, so it's confined to your L2 domain or a VLAN. Okay. Now, in terms of protecting yourselves and rate limiters, you have other rate limiters, which is a broadcast rate limiter and a multicast rate limiter. So you should typically use these in unison. However, you don't have to, you're not forced to, but I guess it was a bit of best practice. We also have an ICMP rate limiter as well that you can use, okay? So in terms of the unknown unicast rate limiter, it's known as a colorblind metering system where you have a credit or a debit effectively on that rate limiter. And then what happens is that you've set your rate, and over certain time slices, very, very small time slices, we see the packets that are transmitting either kilobits or packets per second, depending on the platform. And we let a certain amount of those pass. So under this dotted line, these are forwarded packets. So there's an element of unknown unicast we will forward, okay? Because we're only trying to control it. We're not trying to totally stop it. If you totally stop it, you could have impact elsewhere, because you might need that, for instance, when you get a spanning tree convergence. And anything above that threshold, so will be dropped. And you've done something clever. You've baselined your network. You know what type of traffic you've got on there. Obviously, maybe in an ideal world, and then you're dropping those, because that's pretty much an excess of what you'd expect, what you've baselined in your applications and traffic in your quiescent state, effectively. So, caveat right now, across all platforms, the rate limiter doesn't have any type of statistics or metering. So it's a case of apply it right now, and it's based on what you know in your network. However, circa 10.7, 10.8, we are investigating to have rate limiters that you can see statistics. It'll be platform dependent. However, this would be great if it does get onto those platforms, because you can then baseline your networks. Potentially you can see if you're getting errors on that interface and see what you're dropping and what you're passing. You could even take these into POCs or into sort of a test dev environment in your applications and use our switches as tools there, for instance. So it's quite good. It'll be nice to see that feature down the line. Okay, some configuration and a bit of details and troubleshooting. So you can apply this on an interface. You can apply this on lags and on multi-chassis lags. So across the portfolio, VSX, VSF, and even on lags on a regular switch, right? Obviously ingress, as I said earlier. But however, when you apply on a lag, you will see on the configuration of the actual lag, but actually it's applied on the members of that lag. Okay, so you won't see it in the configuration, but you will see it in the show commands, which I'll show you a bit later. So the rate limiters are kilobits per second or packets per second, depending on the platform. I've listed all the differences here. So in terms of a pre-sales motion, you might need to remember that if you're talking to a customer about the platform and the specific feature. However, if you're on the CLI, if you go into the interface and you put the rate limits unknown unicast, you'll get the option if it's kilobits or packets per second, and you'll get the sort of parameters in terms of what we support in figures here. Now that actually just as an extra, typically you'll find the unknown unicast, the multicast and the broadcast will have the same sort of parameters. Okay. So where can you apply these? Well, typically, if you're doing a rate limiter on an endpoint on an interface, we typically see something like an endpoint on our access switches. If you're putting it on a lag, it could be between another switch, could be another vendor that you don't necessarily trust that well. It could be a large spanning tree environment. You want to put some sort of rate limiting there, because that, if you're getting a lot of spanning tree changes, it's maybe going to protect you. Obviously, you've got some underlying problems there as well that you need to root out. However, this is part of your tool set, okay? And then in a multi-chassis lag, you got VSX. You can apply it if you've got some servers with loads of VMs in them. So again, it's in your toolkit, flexible. You can put it on any interfaces. So we can show where the configuration is applied. You can look at it on the physical interface, or you can go to the subcommand and look at the QoS profile, and it shows it a bit tidier. So here's an example of I've applied a rate limiter on my interface, and I'm looking at interface, and I've got two parameters here. I've got a configured parameter and an actual parameter. And the reason we have this is because some of our platforms, if you configure this, it's not necessarily what is applied down at the ASIC level. So we expose that to our customers and users to show that actually the rate limiter you configured is not exactly what you've actually got. Here in this case, we applied 1,000 packets per second, and our actual rate limiter is working at 1,000 packets per second. I've got some screenshots later that will show you differently, in fact, in the next one. So as I said earlier, we can put the subcommand QoS in, and that's quite nice because it shows you all the QoS parameters that you have. And it's, in this instance, I haven't got any other QoS, it's just a default, but you can see same type of output, but just a bit tidier under the QoS subcommand. And as I mentioned earlier, I've run this again on another platform. It's on 8400. I've got 100,000 packets per second configured as kilobits per second on the rate limiter, but the rate limiter is actually 99,844. So there's a small discrepancy, or what I like to say, granularity in the rate limiter is different on some platforms. Okay, so if you're looking at a lag, I mentioned obviously you've configured it on the lag, and if you do a show interface lag, you'll see it on the lag, the rate limiter configured. However, if you look at the members of that lag, in this case 1128, if we go down and do a show interface there with the subcommand QoS, again the rate limiter is shown on that physical interface, and slightly different, same interface, but just doing a show interface, it's shown under that physical interface. So I guess I've mentioned this already, but it's worth reiterating some of the best practices. The rate limiter shouldn't be seen independent. It should be looked at with other types of traffic. So your multicast, broadcast rate limiters as a triplet. And obviously we have ICMP rate limiter, both for V6 and for V4 as well, actually. So key to this is you really need to understand your network behavior and what applications you have before you start putting rate limiters on there. If you're overzealous and aggressive with your rate limiters, you're going to curtail traffic that actually needs to have broadcast, multicast, and unknown unicast. So you really have to be careful about that. I think the rate limiters, when they come out, when they've got the monitoring function, it'll be good for support to help monitor that. If you've got customers coming back to you with problems, it's a good place to look as a first stop. But really, there's nothing that can really help you more than knowing your network and understanding your traffic flows, which is the age-old thing, right? Where just understanding the network and what's happening on there. So just one thing I wanted to point out: if you've got a rate limiter on a gigabit port, you might say, for instance, have that 100 packets per second. And then you might think, oh, okay, I'm going to apply the same on a 10 gig. Well, you want to be careful about that because you've got more traffic going on that. You mostly got more denser applications, for a word really, on those 10 gig ports. You might want to up those rate limiters slightly as a rule of thumb, maybe a factor of 5 or 6 or 10. But again, you need to know your network to do that. And I guess we have this thing from age old time that we want to segment networks and keep them smaller to stop flooding and impact of this type of traffic, and that still holds true today. If you can segment those networks and keep them smaller, you're going to limit the impacts of this type of traffic. Okay, however, we're now advocating designs that are in large layer 2 domains. So if you look at large venues for wireless networks, and there's a link down here, we advocate large layer 2 domains. Now we do have some sort of tools and knobs and tweaks that we can put on the controllers, but at the end of the day, you have switches that need a lot of high density MAC addresses. So something to watch out for, worth having some rate limiters on there too, because your networks are going to be huge in those domains, especially if it's a large layer 2 domain to support mobility in that type of environment. So, you know, keep your eye out for that type of thing. So there's positive tension between segmenting networks and having large layer 2 domains. And now I'm going to go across to a demo if I can. Okie dokie. Let me explain the setup. So the point of the demo is to first of all show you the behavior of Unknown Unicast, how a rate limiter can help, and show you the behaviors of what can happen when you get a faulty port or a NIC. So I've got a 6300 here in a VSF stack on the right, and on the left I've got an Ixia tester. The Ixia tester has the ability to send traffic to my device under test, and then it will be able to measure or receive the traffic to, and also measures it and gives us an output. So it's a great network traffic tool to test equipment and protocols, okay, for those unfamiliar with it. And this is the Ixia Console. So two important parts really that we need to focus on. This is where I control the traffic, where I send traffic and stop traffic. And on the bottom here, I have where I'm sending. So I'm measuring, I can see what I'm sending in terms of traffic levels. So we have to keep an eye on the TX here, so the transmit rate. And here on the right, I'll see what I'm receiving on these two ports. So we need to look at 112, 212, 214. Port 214 is a control port. So it's basically to show the impact on other ports of Unknown Unicast traffic, or the bad behavior of broadcast and what happens as it transitions. And what I'm actually going to do is try and send traffic from port 112 to 212. But what I'm going to do is I'm going to cause a fault. So I mentioned earlier about the faults and MACs flapping. I'm going to cause that. I'm going to show that happening. I'm going to not have that MAC on this port, and then I'll make it appear later and we'll see what the behaviors are. Okay, so let's go across to the config, and let's see what we've got on the port first of all. And I've got nothing on that port. So port 112, I've got nothing configured on that port. So that's apart from energy efficient Ethernet, so forget that. But I've got nothing configured on that port. I'm in a VLAN 20, so all these ports are in the same layer 2 domain, so all in VLAN 20. And I'm going to hit it with some traffic and see what happens. And I'm already going to have a fault on this port. So this MAC address isn't on here. So if I do a show MAC address table, we're looking for this 092222 on port 212. Well, port 212 doesn't oh, it has appeared, but not with that Mac. Okay, so it hasn't appeared with that Mac. So that's the Mac we're looking for. So it's not on here. Okay, so let's send traffic on port 112 and see what the effect is. Okay, well, there we are. That's what. So on port 212, so 112, I'm sending 760,000 odd packets per second. And this MAC address hasn't appeared, as we can see. Okay, so what's the phenomenon? Well, we've got this unknown unicast turning into a broadcast on all the ports. So this 760,000 packets per second is impacting both these ports, 212 and 214, 760,000 packets. Pretty much a bad thing. You can imagine what can happen in a real network if that was to happen. So let's apply a rate limiter, and I showed you it's quite an easy configuration. Rate limiter, unknown unicast, and then you put a value in. So I'm going to put 250 kilobits per second. Let's see what happens. Wow. And there you can see it immediately as I've applied that rate limiter, I've curtailed the traffic to 250 odd kilobits per second on each of these ports. So if you remember that graph I showed you earlier, these are the forwarded packets, unknown unicast type, but hey, I've now managed to control my traffic, which is a good thing. So I've got some control over my traffic and the behaviors. So I can change this on the fly. So let's put 1,000 kilobits per second. Let's see what happens. Yeah, as soon as I've applied that rate limiter on here at 1,000 kilobits per second on this interface, these two ports have upped, but they're still staying around 1,000 kilobits per second. So the rate limiter is achieving its goal in protecting the network and protecting applications from this blast of unknown unicast traffic. We can also, I think mentioned, go into packets per second. So let's just quickly show you that. So I'm going to do 1,000 packets per second, which is around a half. So it should go to around 500 kilobits per second on here. And yep, there we are. So around 500 kilobits per second as I've applied it and changed the sort of parameter at the end to packets per second for kilobits per second. So what I'm going to do now is I'm going to make this MAC address appear so we can see what the behavior is of the switch, basically. And we should see that actually traffic will start flowing and not impacting other ports, and the rate limiter is no longer used. So let's make the MAC address appear by pressing this play button. And there you are. You can see now that we've gone into a normal behavior. This port 112 here is transmitting 760,000 odd packets per second. However, only port 212 here is receiving that, and port 214 is now back to some quiescent type of low level traffic. It's not being impacted by the unknown unicast traffic. So if we just do a show MAC address again, just okay, we're looking for 222. You can see it's arrived on port 212. So it's normal behavior. Now we can make it go into the show that port bad behavior again. So I have to stop the MAC address being advertised, and then I clear MAC address port 2.1/2, and this should make the fault appear again and my rate limiter that I had at 1,000 packets per second kick in again. So I've cleared the MAC address. Let's see what happens. Yeah, as soon as I've cleared the MAC address, we've got the fault. It can't find its host. So what I'm doing is I'm broadcasting everywhere. Well, the Unknown Unicast is turning into broadcast everywhere, and I'm rate limiting at 500 kilobits per second. So that's really end of the demo. I just wanted to show you one more thing. Actually, it was quite useful. This is on a different platform, 8400. I did show you it in my slides, but I want to show you it live. You can see I've applied this on an interface packet, million packets per kilobits per second, but the actual is actually showing at 990,000 odd. So there's the differential in the AOS-CX, so the granularity. If I show interface 1/1/2, you'll see that you can see the rate limiter here. The actual matches, but has in this platform, it was slightly different. Okay, so that ends the demonstration and my part of the TOI.